Topic 1, Earth, Sun, Moon Systems, Lesson 3, Phases and Eclipses, page 26 to 34. All right, the connected. Observe the moon. Draw several other shapes you have seen the moon take. So you should draw those around where the moon is. They should look something like this. What might cause these changes? As the moon orbits Earth, we see it in different ways. The changing relative positions of the moon, Earth, and sun cause the phases of the moon. And how is Earth affected by the moon? The pull of gravity from the moon affects the tides on Earth. The appearance of the moon. So phases, the different shapes of the moon you see caused by the motions of the moon around the Earth. The two sides of the moon. A full moon may look like a face, but you are actually seeing some of the most dramatic features of the moon. Marea is the dark-colored areas of the moon, which are low, flat plains of lava and the bright patterns that indicate highland areas, often dotted with craters. These distinctive features never move because the same side of the moon, the near side, always faces the Earth. The side that faces away is called the dark side. Motions of the Earth. The moon rotates and revolves like the Earth. The moon rotates once on its axis in the same time it takes to revolve once around Earth. A day on the moon is the same length as their year. It is also why we see the same side of the moon from Earth. Half of the moon is always lit by the sun. The amount lit is always the same. But because the moon orbits the Earth, part of the lit surface visible from Earth changes in a predictable pattern. Lunar motion, figure 2. This diagram shows the rotation and revolution of the moon. Add a drawing of a face on the two remaining images of the moon to show how the moon is facing Earth at each phase. How would the moon appear from Earth if the moon did not rotate? So people on Earth would be able to see all sides of the moon instead of only the same side. Phases of the moon. A new moon is the moon when it's between the Earth and the sun. The side of the moon facing Earth is dark, and the opposite side of the moon faces the sun. As the moon revolves around the Earth, the side you see becomes more illuminated by direct sunlight. After a week, the angle formed by the sun, moon, and Earth is about 90 degrees. We see the first quarter moon, half lit, half dark. Halfway through the moon's revolution, we see full lit or full moon. A week later, sun shining on the other half creates the third quarter moon, half of the lit side. In 29 and a half days, the pattern begins again. All right, so reading check. Use figure 3 to describe what is happening during a waning crescent. And then also in the empty circle, draw what a waning crescent moon looks like from Earth. So that's what we did here. That's what I just popped up. A waning crescent is that. The answer to our reading check is during a waning crescent moon, the moon is nearly in a line with the sun and Earth. So most of the lit parts of the moon is facing away from Earth. From Earth, you see only a small crescent moon. All right, so we're going to draw an X on each diagram to show a spot where each eclipse can be seen. Add labels for the Earth's penumbra and umbra in the lunar eclipse diagram. Mark a P to show the places a moon could be during a partial lunar eclipse. So I have these split into two separate images. So first we have a solar eclipse, which occurs when the moon passes directly between Earth and the sun, blocking the sun's light. The shadow of the moon is then cast on Earth. From Earth, the sun appears covered and is dark, with only the corona showing. A solar eclipse can only happen during a new moon. Then a lunar eclipse. So a lunar eclipse occurs during a full moon when Earth is directly between the moon and the sun. During a lunar eclipse, Earth blocks sunlight from reaching the moon. Lunar eclipses occur only when there is a full moon because the moon is closest to Earth's shadow at that time. During most months, the moon moves near Earth's shadow, but not quite into it. And then here we have everything marked. Make sure that you have the X on the solar eclipse, and then the X and the umbra and the two P's and the penumbra on the lunar eclipse. Eclipses. So an eclipse occurs when an object in space comes between the sun and a third object, causing a shadow on the third object. The plane of the moon's orbit around Earth is off by about 5 degrees from the plane of Earth's orbit around the sun. Most months, the shadow cast by Earth or moon misses the other object. So umbra, the very darkest part of the shadow where the light from the sun is completely blocked. Only those within the umbra experience a total solar eclipse. Because a lunar eclipse is visible from every point on Earth's night side, more people can view a total lunar eclipse than a total solar eclipse. The penumbra is the area of the shadow where the sun is only partially blocked. So here we have the image, and it shows where the moon is, where the umbra is, where there's that extra dark spot. The penumbra is when there's the additional shading on the outsides from it being covered. So reading check, why isn't there an eclipse every month? And the plane of the moon's orbit around Earth is not aligned with the plane of Earth's orbit around the sun. So the sun, the moon, and Earth rarely line up. All right, so our model it. Solar and lunar eclipses. Solar and lunar eclipses occur when the sun, moon, and Earth are perfectly aligned. How could you represent Earth, the moon, and the sun during an eclipse? Using real objects to create a model of a solar eclipse and a lunar eclipse. Think about what you could use as a light source to represent the sun. What positions would your objects need to be in to illustrate each type of eclipse? Draw and label the plan for your models. So, for an idea, for a solar eclipse, Earth, Moon, Sun, you could use a flashlight for the sun, a tennis ball for the moon, and a softball for the Earth. For a lunar eclipse, Sun, Earth, Moon, you could use the same items as the solar eclipse. So then we would use the sun, and then the softball, and then the tennis ball. All right, moving on to tides. Tides are the rise and fall of ocean water that occurs approximately every 12.5 hours. They result from the gravitational differences in the Earth, Moon, and Sun alignments. The water rises for about 6 hours, then falls for 6 hours. The moon and the sun. So the moon's gravity pulls more strongly on the side facing the moon. The pull causes the ocean water to bulge on that side of Earth. Another bulge forms on the side of Earth further from the moon, where the pull is weaker. It causes the formation of high tides in both locations and low tides in between. As Earth rotates, bulges shift with the moon for 2 high tides and 2 low tides at a given location. The sun's pull on Earth is much stronger than the moon's, but it is so much further away that the differences at the near and far side are small. So the sun cannot cancel out the moon's effect, but it does influence it. Changes in the positions of the moon and sun affect the level of tides over the month. All right, so for the math toolbox, high and low tides. Tides are measured at different locations by choosing a reference height and then determining how far above that height the water rises. The table shows approximate data for high and low tides in Nags Head, North Carolina, in November 2016. So which tide has the greatest change in centimeters? What was the difference? So the difference was greatest on November 27th. The difference was 106.6 centimeters. Which of the dates was most likely the closest to a new moon? Explain. The new moon was most likely closest to November 27th when the high tide was higher and the low tide was lower. All right, spring tide. When the gravitational pulls from the sun and moon combine to produce a tide with the most significant difference between consecutive low and high tides. During first and third quarter moon phases, the line between Earth and the sun is at a right angle to the line between Earth and the moon. Because the sun and moon are pulling in different directions, their gravitational pulls partially cancel each other. The result is more moderate tides. Now, neap tide is a tide with the least difference between consecutive low and high tides. Figure 5. Spring and neap tides occur twice a month. Shade in the bulges that occur during the neap tide. So, for the neap tide, you should have a bulge at the top, a bulge at the bottom. And let's do the reading check. What causes high and low tides? High and low ocean tides are caused by differences in the strength of the gravitational pull of the moon and sun on different parts of Earth. And that finishes the lesson 3. So now it's time for our lesson 3 check. So 1, why does the moon have phases? As the moon revolves around Earth, the relative positions of the moon, Earth, and the sun change. The phase of the moon, you see, depends on how much of the sunlit side of the moon faces Earth. 2, in what positions are the sun, moon, and Earth during a full moon? So during a full moon, Earth is between the sun and the moon. 3, what causes a total lunar eclipse? A total lunar eclipse occurs when Earth is directly between the moon and the sun. Earth blocks the sunlight and the entire moon is in the shadow cast by Earth. 4, under what circumstances might you be able to view a partial solar eclipse instead of a full solar eclipse? So your position on Earth affects whether you see a full or partial eclipse. People within the darkest area of the shadow, the umbra, see a total eclipse. If you are in the penumbra, you will see a partial eclipse. 5, what would you expect the tides to be like during a first quarter moon? During the quarter moons, Earth experiences neap tides, which are moderate because the pull of the sun and moon are at right angles to each other. And that finishes lesson 3. Thank you so much.